These are example problems from the study island topic, construct two-way tables in the eighth grade. Let's get started. Number one, the head of a store's customer service department gathered data from a sample of customers making returns about whether they had a receipt and whether the item being returned had been opened. The two-way table displays the relative frequencies of the data. So before we get into the problem, let's make sure we know how to read this table. Of all the people that had a receipt when they returned the item, it says 0.55 here. That's 55%. And here's 0.45. That's 45%. 55% and 45% add up to 100%. So, of the people that had a receipt when they returned the item, 55% of them had opened it, and 45% of them, the package was unopened. Now, if you look at the no receipt row, for the people that returned an item without a receipt, 42% had opened it and 58% had not opened it. And those, again, add up to 100% of the people with no receipt. So let's look at the question. Based on the relative frequencies of the table, which two-way table is a possible representation of the data collected? See, this is called a relative frequency table because it uses the percentages of the rows, or if it were column relative, it would have percentages of the columns. But this is a row relative table because the rows add up to 100%. If it were column relative, the columns would add up to 100%. Since the percentages are in there, it's relative frequency. We want to know which two-way table is a representation of this relative frequency table. These are the raw numbers in all of these four choices that we have. We want to know which one of these tables with the raw numbers matches these percentages. So let's check it out. Take a look at choice A. For the people who had a receipt, 41 of them had the package opened and 16, it was unopened. So what numbers are those? You could plug it into a calculator pretty quickly and get your answer. Here's my calculator. If 41 had an open package and 16 had an unopened package, then how many people had a receipt total? 41 plus 16 is 57. So what is 41 out of 57? Now notice when I said out of, I hit the divided by button. 41 out of 57 is 41 divided by 57. I'm figuring out what percent 41 is of 57 right now. And the answer is, it's about 72%, 71.9%. So about 72%. That doesn't match up with what we have here. We want it to be 55% of the total. Since 41 is not 55% of the total of this row, A is not the answer. I don't even have to check the rest of these. Let's go on to B. 31 opened, 25 unopened for the people that returned it with a receipt. 31 is what percent of the total for the row? Again, the total for the row is these two numbers added together. 31 and 25 is 56. So what percent is 31 out of 56? 31 divided by 56 equals 0.55. Now that rounds to 55%, though it's not quite, it's a little higher. If we round to the nearest percent, that's 55%. So that looks pretty good. Then 25, that means we'll round to the 45%. 25 out of, again, the total, 56, equals 0.446. That's 44.6%. So again, that rounds to 45%. So these numbers do work. Now we have to check the no receipt numbers. We want this number right here, the number that did not have a receipt and had an open package. We want that, which is 13, to be 42% of the total for that row. So what is the total for the no receipt row? 13 plus 18 is 31. So what percent is 13 out of 31? 13 divided by 31 is equal to 0.419, which again would round to 42%. So this is going to be our answer. 18 out of the same 31 is going to round to the 58%. So there we go. B is our answer. How do we know that C and D are not our answers? Well, we could just check our very first number and we'll see if they match up, and we'll just go until we see a mistake. 51 and 17 for the receipt row. That means the total for the receipt row in C, option C, is 68. 51 divided by 68 is 75%. So in option C, 75% of the people that returned it with a receipt had an open package. That does not match the 55% we're looking for, so we can move on to the next choice. And the next choice is D. We have 35 out of a total of 50, because 35 plus 15 is 50. So again, 50 people returned it with a receipt. 35 of them had an open package. 35 divided by 50 is equal to 0.7. That's equal to 70%. And again, that's not the 55% we're looking for. So those are definitely not it. And B is our answer. So just as a quick review, if you have a relative frequency table, which has the percentages in there, or the decimals you can convert to percentages, the two-way table that will reflect those will be the total of a row or column based on where the relative frequencies are totaling. In these, we can see the total is the total of the rows. So all we have to do is find the percentages and then look at which table has numbers that match those percentages. The answer here was B, because the receipt row had a total of 56 people in it. 31 out of 56 is 55%. 25 out of 56 is 45%. And then the no receipt row had 31 people in it. And 13 out of 31 is 42%. 18 out of 31 is 58%. So this is why that matches up. Let's do another problem. Number 2, a principal collected data from 8th grade students about whether or not they are in band and whether or not they are in choir. The information collected is shown below. 26 students are in band and choir. 32 students are in choir and not band. 43 students are in band and not choir. And 19 students are in neither band nor choir. So which two-way table represents the data collected? Okay, so this is pretty simple. We just got to match up these numbers with what these tables say. So let's go ahead and look for the very first one, 26. 26 students are in band and choir. So we want to find the table that says band and choir in 26. W has that. There are 26 people in band and choir. So when I look at the table for W, the people who are in band, there's 26 that are in band and choir, and there's 43 that are in band but not choir. The first number we're looking for is 26, so this table matches that so far. What other option also has 26 there? And it's option Z, 26 in band and choir. X does not match because it says there's only 19 in band and choir. Y does not match because it says there's 32 in band and choir. So with just the very first number that they gave us, we've already eliminated half of our options, and we know it has to be table W or table Z. Let's look at the next number it gives us. It says 32 students are in choir and not band. So which one of these tables say 32 for choir and not band? When I go in the choir row, here's a 32 right there. And it says 32 are in choir and not band. So that matches up. The other table also has 32 in choir. Excuse me. So since both of these tables say that there are 26 in band and choir and 32 in choir but not band, we still have to go on to our third number to check for that. 43 students are in band but not choir. So which one of these tables that we are trying to choose from has 43 students in the band column with not choir? So right here, band, not choir, 43. That matches. What about here? Band and not choir, only 19. The 43 is in the not band and not choir. That would be neither band nor choir. So that means that choice W is the only one that works. 19 students are in neither band nor choir. It says it right there. Those four numbers match up. Next problem. Number 3, Callie surveyed 40 students at her school to see how many have dogs and or cats. She found that 40% of students who have dogs don't have cats. Complete the table below. All right, so there are 40 students at her school that she surveyed. 40% of them that have dogs don't have cats. This is a very important sentence. Want to make sure that you're interpreting it correctly, so pay attention. She found that 40% of students who have dogs don't have cats. Not 40% of the students total, but of the students who have dogs, 40% of them do not have cats. So we can use that information to fill out the rest of the table. First, how many students have dogs? 25. It says right here, the have dogs column, the total is 25. So 25 of the 40 students have dogs, which means 15 of the students do not. Of the students who have dogs, 40% do not have cats. So all you have to do is calculate what 40% of 25 is. Now, hopefully this is something you can do in your head, but if you can't, that's okay. You can use your calculator. 40% is 0.4. And if you want a percent of a number, you multiply, so 0.4 times 25. 0.4 times 25 will give you 40% of 25, and there's your answer, 10. So all I have to do now is go to the section of the table that says have dogs, don't have cats, and put that number 10. Now, if there are 25 total students that have dogs, and 10 of those 25 don't have cats, well, then 15 must have cats and dogs. Remember, this column has to add up to 25. There has to be 25 people that have dogs. So if 40% of those 25 don't have cats, then the other 60% do have cats. They have to add up to 25. 10 plus 15 is 25. Now it's a pretty simple adding problem to get the totals for each row. If there are 15 of the people that have cats that have dogs, and 7 of the people that have cats don't have dogs, that adds up to 22 people total that have cats. Then, if there's 40 people total and 22 of them have cats, that means the other 18 don't have cats. And these two numbers had better add up to 18. 10 plus 8 is 18. 22 plus 18 is 40. Everything adds up like it's supposed to, and there we go. Next problem. Number 4, a hotel manager gathered data about whether the 118 rooms in her hotel are suites or standard rooms, and whether or not they have a king-sized bed. A summary of the data she gathered is shown. 25 rooms are suites and have a king bed. There are a total of 48 suites in the hotel. A total of 40 rooms at the hotel have a king bed. So which two-way table represents the data gathered by the hotel manager? So just like the last problem that was similar to this, let's go through the data one at a time and eliminate our choices. First, 25 rooms are suites and have a king bed. Well, each one of these tables has the suite or not a suite in rows and the king bed or no king bed in columns. So we find the intersection of the suite and king bed and see which ones say 25. Table A has a 25 there for suite and king bed, so that works. Table B also has a 25 for suite and king bed. Table C and table D. All 4 choices have the 25 there, so this clue doesn't help us at all in eliminating any of our choices. Next, there are a total of 48 suites in the hotel room, or in the hotel. That means that the suite row has to add up to 48 total. So which of these tables have a suite row that adds up to 48? Table A has 25 and 48. That makes way more than 48. 25 plus 48 is obviously more than 48, so table A is not the right table. Table B, 25 plus 23 is 48, so that could be one of our options. Table C, 25 plus 15, that is only 40, so that's no good. And table D, 25 plus 48, again, makes more than 48 total suites. So the only table that fits that one requirement for this problem is table B. Now, we could also check to make sure that we didn't make a mistake by making sure that our table B satisfies the last requirement, which was a total of 40 rooms at the hotel have a king bed. So if I go over to the king bed column in the table that we selected, will they add up to 40? 25 plus 15 is 40. So yes, our table that we are selecting does have 40 king beds. Next up, number 5. A newspaper reporter surveyed a sample of area residents about whether they knew the local high school team won a conference championship and whether they had family members attending the school. The two-way table shows the data collected. So here we've got our table. Let's jump right into the problem. When the values in the table are rounded to the nearest hundredth, which table correctly displays the row relative frequency for this data set? So that's a very important word in there, row relative. That means that the percentages for the rows must add up to 100%, or the decimals, which are rounded to the nearest hundredth, have to add up to 1.0. So let's just check that first, because it has to be row relative. The rows have to add up to 100%, or 1.0. So table A, does 0.87 plus 0.38 add up to 100%? No, it does not. So A is not an answer. If you can't do that and see it in your head, you can always plug it into a calculator. 0.87 plus 0.38 equals 1.25. That would be 125%, 1.25. That is too much. I don't even need to check the next row. I know that this table is not the answer we're looking for. Plus, the second row, the no family members attending the school row, also doesn't add up to 100%. So A is not the answer. What about B? 0.65 and 0.35. That does add up to 1.0. 0.65 plus 0.35 is 1.0. So 65% plus 35% adds up to 100%. So far, this is a possibility. Similarly, 0.15 and 0.85 add up to 100%. So table B might be one of our answers. Let's check table C. 0.39 and 0.21 definitely don't add up to 1.0 or 100%, so that's not the right answer. And table D, 0.64 and 0.26. What do those add up to? 0.64 plus 0.26, not going to be enough. Only 0.9. That's 90% and not the entire 100%. So without even knowing any numbers, we can tell that this table is the right one because it's the only one of the 4 options that we have where the rows add up to 100%. And if it's a row relative frequency, then the rows must add up to 100%. Now, if I use the numbers, how could we get these numbers? 79 knew that there was a championship game and had family members attending the school. If I take 79 people, and I divide by the total for this row, what do I get? Well, the total for the row is 79 plus 42. That's 121. So 79 divided by 121 equals 0.65. Well, it's 0.6528, but rounded to the nearest hundredth, it's 0.65. Then you get 42 divided by 121, and you get the 0.347, which rounds to 0.35 in the nearest hundredth. And that's where these numbers come from. The next one, 0.15 and 0.85. 12 knew there was a championship game and had no family members attending the school. 69 did not know there was a championship game and had no family members attending the school. So how many people did not have family members attending the school? 12 plus 69 is 81. So 12 divided by 81 tells us what portion of the no family members attending the school row knew there was a championship game. And that is 0.148, which rounds to the nearest hundredth of 0.15, which is the number that we want right here, 0.15. And then the 0.85 will also show up there if, again, you take the value in this box and divide it by the total for that row. 69 divided by 81 gets us our 0.85 rounded to the nearest hundredth, and that's the answer. Next up, number 6. Rick surveyed 50 students at his school to see how many have after-school jobs and how many are getting the new video game console that is coming out next month. From his data, 30% of the students are getting the new console. Also, of the 20 students who have after-school jobs, 45% are getting the new console. Using this information, complete the following table with the relative frequency of the columns. We are doing column relative frequency this time, not row relative. It's very important that you notice whether it's a row or column that you are trying to find the relative frequency for. Since this is relative frequency of the columns, it's the columns this time that have to add up to 100%. So let's break down the numbers that it gave us again. From his data, 30% of the students are getting the new console. That's 30% of the students, period. So when we are looking at this table, we have to make sure that the section that says getting the new console is 30% of all the total students that he surveyed. Now, where does it say getting the new console? It says it right here. So the getting the new console is a row. 30% of the total kids are getting the new console. So the decimal that stands for 30%, which is 0.30, goes in the total right there. Now, if 30% are getting the new console, that means 70% or 0.70 are not. So the 0.7 must go there. And the total of 30% and 70% must be 100%. 0.3 and 0.7, 1.0. So there is 1.0 for there. Now, again, this is a column relative table. Each column has to add up to 100%. So we can go ahead and fill in the 100% or 1.0 into the end of each of those columns. Finally, we need a little bit more data in order to fill in the rest of the table. And here it is. It says, of the 20 students who have after school jobs, so not 20% of the students total, but 20% of the students who have after school jobs, 45% are getting the new console. So 20 students out of 50 have after school jobs. So of the 20 students who have after school jobs, that means 20 out of 50 have after school jobs. Well, what percent is 20 out of 50? That's 40%. But notice that we don't need 40% in the totals. Again, we are doing column relative. So we don't want the 40% to be down here. We want the columns to add up to 100%. So don't get caught up on that part. Use this calculation in order to help solve the problem. 45% of those 20 kids are getting the new console. So let's find the section where it says have after school jobs. That's this column right here, the have after school job column. There are 20 kids that are going to fit in this column. 45% of them are getting the new console. So we take our 45%, have after school jobs, getting the new console, and we drop it in. So if 45% of them are getting the new console, that means 55% of them are not. So there you go. Now, to fill out the rest of this, we have to look at a couple more things. We need to remember that 30% of all the kids are getting the new console. Well, how many kids is that? What is 30% of all the kids that we surveyed? If we bring up a calculator, it's a pretty easy calculation to plug in here. 30% is 0.3. We multiply that by the total number of kids, 50, and we get 15. So we know that 15 kids are getting the new console. So this number of kids is 15. Well, how many of those kids getting the new console right here have after school jobs? We can calculate that as well. Remember that 45% is 45% of 20. So we can calculate 45% of 20. 0.45 times 20 equals 9. So the total for the row is 15. The number getting the new console that have after school jobs is 9. That means this number right here, the number that are getting the new console and don't have after school jobs, is 6. So we just have to remember that number 6. You could jot it down somewhere. 6. So it's in there. I don't know why I said times 6. Excuse me. We just have 6. My calculator keeps wanting to repeat the times 20 that I did with the 45%. That's okay. Keep the 6 in your head or jot it down somewhere because 6 kids go right here. Now, if we can figure out how many kids go right here in this spot, that's the number that don't have an after school job and are not getting the new console, then we can convert those into percentages. Let's start by doing the same thing we did for the last problem. 70% of the total is what is in this box right here. Now, we just figured out that 15 is the total for getting the new console. If there were 50 kids total, then 15 in this box have to add up to 50. So 15 plus 35. So the not getting the new console row has to add up to 35. If you have 55% of these, that's 55% of the have after school job crowd is not getting the new console, then we can also convert that into a number. Remember, 45% of 20 was 9. So this is 55% of 20, which must be 11. It has to be the other set of kids that make up the 20 because it has to add up to 100%. Now I'm going to go ahead and write this down because I can already imagine some of you losing track of my voice. So what I've done here is I've recreated the table that this problem is giving us in order to put in the raw numbers. That way, this is a little bit of an easier problem to follow. We start off by saying that they surveyed 50 kids. So the total has to be 50. That's the first number we can put in, and we know that for sure. Now, I'm going to do a quick adjustment for the font to make that easier to read. And there we go. So 50 kids. Now, again, 30% of the students, according to the problem, are getting the new console. And when we did 30%, 0.3 times 50, we got 15 kids. So we know that this spot right here is 15. Well, if that's 15 and the total is 50 kids, then this has to be 35 because 50 minus the 15 means that there's 35 remaining. Now we can go over to the have after school job column. It told us that of the 20 students who have after school jobs, so this total is 20 kids, 45% of them are getting the new console. So 0.45 is 45% times the 20 kids total is equal to 9. So there's a 9 in this box. This is the box for kids who have an after school job and are getting the new console. That means that this value right here must be 11 because 9 plus 11 adds up to the 20 total. Then over here, we have to have a total for this row of 15 kids because we know that 15 kids are getting the new console, which means this number has to be 6. And finally, this right here has to be whatever adds to 11 to make 35, and that's 24. That clearly means that there are 30 kids that do not have an after school job, which stands to reason because we already knew that 20 do have an after school job and the total number of kids surveyed was 50. So if 20 have an after school job and there's 50 kids total, that means 30 do not have an after school job. So now that we have a complete table with all the raw numbers in it, we can turn these into relative frequencies a little bit more easily. Again, we care about the total for the columns in this. So when we turn in a relative frequency table that's column relative for this set of raw numbers, for this two-way table, we want to know what each of these values is out of the total for the column. So what is 6 out of 30 as a percentage? 6 divided by 30 is 0.2. That's 20%. So we fill that into our table. And again, the percentages have to add up to 100% because we care about the total for the columns. So this must be 80%. And if I plugged in 24 divided by 30, it would give me 80% as well. And there we go. There's our 0.8. So we know we've got it right. Next problem. Number 7, Lisa gathered data from a sample of accounts on a social media site about whether or not the account owners made their first name and location visible to the public. The two-way table displays the relative frequency of the data. So this is a relative frequency table, and you should be able to tell right away that this is a column relative frequency table because the totals of the columns are 100% or 1.0. Based on the relative frequencies of the table, which two-way table is a possible representation of the data collected? So we just need to figure out which sets of numbers match these percentages. Let's figure it out. For table A, if there are 48 that have their first name visible and a location visible, and 12 that have their first name not visible and their location visible, what would be the relative frequencies for this column? Just take a look at the column. You can completely ignore the other column right now. You can ignore the location not visible numbers because we are looking at a column relative frequency table on the top. 48 is what percent out of the total for the column? Well, what is the what is the total for this column? There are 48 plus 12, that's 60. So all you have to do to get the relative frequency is figure out what percent 48 is out of 60, and you're on your way. 48 divided by 60 is equal to 0.8. That's 80%. We don't want it to be 80%. We want it to be 68%, 0.68. So A is not going to be our answer. Let's move on to B. What percent do we have for these? 57 out of the total for the column. The total for the column is 57 plus 6, which is 63. So we figure out what percent 57 divided by 63 gives us. And we have 0.90. 0.904 rounds to 0.90. That's 90%. Again, much more than the 68% we're looking for. B is not going to be our answer. Moving on to C. 58 and 31 in this column. What is 58 plus 31? That's 89. What percent is 58 out of 89? We get 0.6516. So not quite 68%, but much closer. This rounds to 65%. So we really better hope that D is our answer, or else we were doing something wrong. 26 and 12. 26 plus 12 adds up to 38. What percent is 26 divided by 38? That gives us 0.68. That's what we were looking for. This rounds to 0.68, 0.6842. So finally, D gives us our answer, and we're pretty sure that's it, but we can double check to make sure that we didn't do anything wrong by making sure that the other numbers fit as well. 12 out of that total, 12 out of 38, had better give us 32%. So 12 divided by 38 equals, sure enough, 0.315 rounds to 32% if you're rounding to the nearest percent. And now we can check the other column finally. 39 and 49 adds up. You can always use your calculator if you want to 88. What percent is 39 out of 88? Just do 39 divided by 88, and you get 0.4431818 repeating. So 0.44 is 44% if you round to the nearest percent. And sure enough, 44% is what we see there, 0.44. 49 out of 88 will give us a number that rounds to 56%. And so we know we got the right answer. Let's keep rolling right along. 65 students were asked whether or not they like to watch comedies or dramas. The results of the poll are as follows. 10 students do not like comedies or dramas. 21 students like comedies but not dramas, etc., etc. Let's see the question here. Which two-way table represents the information found in the poll? Let's start with one thing at a time. Which of these tables says that 10 students do not like comedies or dramas? They don't like either one. Do not like comedies or dramas. Find the table that has 10 kids that do not like comedies or dramas. Table W, I go to the does not like comedies column, and I see a 10, but that's in the likes dramas row. I want the 10 to be in the does not like comedies column and the does not like dramas row. So W is out because there's an 11 in that spot where I want there to be a 10. Table X does have a 10 in that spot. 10 does not like comedies, does not like dramas. There's a 10 there. Check the other ones just in case. Y also has a 10 there, so it's a possible option. And Z has a 10 there, also a possible option. So 3 of these 4 tables fit the first requirement for this problem, that 10 students do not like comedies or dramas. The next requirement we can check. 21 students like comedies, but not dramas. So of the 3 options we have remaining, that's table X, table Y, table Z, which one of those has 21 students that like comedies, but not dramas? So we go to the likes comedies column, and we find the does not like dramas row, and we see if it has a 21 there. This one has a 21 in the likes comedies column, but that 21 is in the likes dramas row. We want them to like comedies, but not dramas. So there's a 23 in that spot for table X. Table X is not going to be the answer. But Y and Z both have a 21 in the appropriate place. So now we're down to Y or Z as an answer to this problem. Next requirement, 11 students like dramas, but not comedies. Where is the likes dramas, but not comedies section of each of these tables? For Y, the section that says likes dramas and does not like comedies has a 14 in it. That is not what we want. We want it to be an 11, and the one that has an 11 is table Z. So through process of elimination, we know that this is the answer. You don't even need to check the last requirement, but we will anyway. 23 students like comedies and dramas, and sure enough, the table we're selecting has a 23 in the section of the table that represents those who like comedies and dramas. So Z is our answer. Next question. Number 9. A local planning commission surveyed 187 people to see if they preferred to pay for curbside recycling or have a free drop-off location for their recycling. The table shows the results of the survey. So they broke it up into age groups and then whether or not they wanted curbside or drop-off location. How many of the people surveyed are ages 46 to 75 and prefer curbside recycling? Now remember, it says in the problem that 187 people were surveyed. It gives us 3 of the 4 sections in the table. So we just need to find that last section by figuring out who is missing from the 187 surveyed people. So here we go. You have 187 total people. Take away the 26 that are ages 18 to 45 and want curbside recycling. So 187 minus the 26, and then subtract the 67 that are also ages 18 to 45 but want a drop-off location, and then finally subtract the 38 that are ages 46 to 75 and want a drop-off location. That leaves us with 56 people, and that's the answer for this problem. Last question, number 10. Isaac gathered data from a sample of mall shoppers about the places they plan to visit while at the mall. The two-way table displays the relative frequencies of the data. So again, we have a column relative frequency table. Notice the columns add up to 100%. Based on the relative frequencies of the table, which two-way table is a possible representation? So let's do it. Right here for choice A, 27 want the food court, and there's fewer than 3 stores. 27 and 11 make a column total, 27 and 11, make a column total of 38. So what percent is 27 out of 38? 27 divided by 38 gives us 0.710. That is a 71%. That is clearly not what we want, which is 38%. Now, did we really even need to punch that into a calculator, or could we tell that 27 is more than half of the column? And since this is less than 50%, that's obviously not it. Table B. 18 right here plus 29. That gives us a total of 47. So what is 18 out of 47? 18 out of 47 is 0.3829. That rounds to 0.38 if we're rounding to the nearest hundredth or the nearest percent, which is 38%, and that's what we want. Let's check 29 now. 29 out of 47 obviously has to be the 62% because they have to add up to 100%. So 0.62 if you round to the nearest hundredth, because 0.617 rounds to 0.62. So the column works. Let's check the other column, the no food court column. This 45 right here, we want it to be 76% of the total for the column. So let's figure it out. 45 and 14 is 59. So what percent is 45 out of 59? 45 divided by 59 is 0.762. So again, that rounds to 76%, and 14 out of 59 is going to give us that minus 1, or excuse me, 1 minus that, which is 0.237, and again rounds to 24%, which is the number we're looking for right here. So B works. C does not work. 13 and 16 add up to 29. 13 out of 29 right away is going to give us a number that we don't want, which is 0.448 or 45%, not the 38% we were looking for. And 28 and 52, those add up to 80. 28 out of 52 gives us 0.53. Or excuse me, not 28 out of 52. I want 28 out of 80. I don't know why I just said 28 out of 52. 28 plus 52 is 80. 28 out of 80 gives us 0.35, and we don't want 0.35. We want 0.38. So B is the only answer. And that's it for this video. Work hard and make sure that you are reading the lessons when you do these study island topics. It's always good to have the lessons on in the background to refer to as you're doing the problems. And there are lots of really good examples that they provide for you on a couple of pages. So if you're not reading through the lessons before you actually try the practice problems, you're missing out. Good luck. Work hard.